Good morning, my dear students. This is the revision part 3 of chapter 3, playing with numbers. The first topic is factors. A factor of a number is an exact divisor of that number. So, first question is find the factors of 12. That means we have to find the numbers by which 12 is exactly divisible. So I can show you that 12 is divisible by 1. The quotient is 12. 12 is divisible by 2. The quotient is 6. There is no remainder. 12 is divisible by 3. The quotient is 4. There is no remainder. If I divide 12 by 5, there will be quotient 2 and remainder 2. So 5 is not a factor of 12. So the factors of 12 are 1, 2, 3, 4, 6 and 12. Multiples. The multiples of a number are obtained by multiplying it by natural numbers 1, 2, 3, 4, 5, 6 like this. Question. Write 5 multiples of 5. So we have to write 5 multiples of number 5. So first I can write that 5 into 1 is equal to 5, 5 into 2 is 10, 5 into 3 is 15, 5 into 4 is 20, 5 into 5 is 25. Therefore, the multiples of 5 are 5, 10, 15, 20 and 25. Next question, write 2 common multiples of 2, 3 and 5. So, we have to check the common multiples. That means the common multiples of 2, 3 and 5 we have to find. So 2 into 6 is 12, 3 into 4 is 12, 4 into 3 is 12. So 12 is the common multiple. Again 2 into 12 is 24, 3 into 8 is 24, 4 into 6 is 24. So in the three conditions, in the three situations, we have got the multiple 24. Therefore, the common multiples of 2, 3 and 5 are 12 and 24. I have mentioned only 2 common multiples. If you are asked to find more multiples, then you have to check with more multiples of the given numbers. The prime numbers. A natural number which is greater than 1 and whose only factors are 1 and the number itself is called a prime number. That means a prime number has only 2 factors, 1 and the number itself. One important note is the first natural number 1 is neither a prime number nor a composite number. A composite number has factors more than 2. I have given you the list of prime numbers starting from 1 to 100. So, there are 25 prime numbers in first 100 natural numbers. Those are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 57, 61, 67, 71, 73, 79, 83, 89 and 97. The smallest prime number is 2 and the smallest composite number is 4. Coprime numbers. Any two numbers which have no common factor other than 1 are called coprime numbers. It means any two prime numbers are always coprime. Give examples of coprime numbers. So 2 and 13 have only 1 as common factor. 5 and 11, 19 and 29, the two prime numbers, any two prime numbers are always coprime numbers. Then twin prime numbers. A pair of prime numbers which differ by 2 are called twin prime numbers. Differ means that if the difference between two prime numbers is 2, then the two prime numbers are twin prime numbers. Question: give examples of twin prime numbers. 3 and 5 are both prime numbers. So if we subtract 3 from 5, we get 2. 5 and 7 both are prime numbers. If we subtract 5 from 7, we get 2. 3 and 11, 29 and 31 are example of twin prime numbers. You can find more pairs of twin prime numbers from the list I have given to you. You try. Next topic is divisibility test. Divisibility by 3 and 9. A number is divisible by 3 if the sum of the digits of the number is divisible by 3. So, if a number is given, what we have to do to check if it is divisible by 3 or not? We have to add the digits of the number. So, here the number is given to us is 29139. So, we have to find the sum of the digits. The sum of the digits is 24. 24 is divisible by 3. So, the given number is also divisible by 3. Next question, check if 29139 is divisible by 9 or not. We have to check 29139. The sum of the digits is 24. If 24 is divisible by 9 or not. 24 is not divisible by 9. So, 29139 is not divisible by 9. So, the sum of the digits, we have to check if it is divisible by 9 or not, to check if the number is divisible by 9 or not. Next is divisibility by 5. If the last digit of a number is either 0 or 5, then the number given is divisible by 5. Is 25050 divisible by 5? Yes, because the last digit is 0 of the number 25050. The next important topic is prime factorization. The factors of a number can be split up till they are all prime numbers. So, we can split up the given number by a division method, short division method. How we can do? We can see in the example. Question: express as product of primes, or find the prime factors of 30. The same. So, if we divide 30 by 2, we get 15. If 15 is divided by 3, we get 5. Again, 5 is divided by 5, we get 1. So, here the important point is you have to do the division with only prime numbers, and it has to begin with the smallest prime number. If it is not divisible by 2, you can try to divide the number by 3. If the number is not divisible by 3, you can go for the next prime number 5. So, remember, you have to divide the numbers by prime number and begin with the smallest prime number. So, here 30 as if we express it as product of primes, it will be 2 into 3 into 5. The next question is, draw the factor 3 of 20. So, you can see in the slide, if I divide 20 by 2, I get 10. If I divide 10 by 2, I get 5. If I divide 5 by 5, we get 1. So what I can write? 20 in the first row. 20 is splitted into two factors, 2 and 10. Then 2 is a prime number, so we have to leave there itself. Again 10 is not a prime number. We can split 10 into two prime numbers, 2 and 5. 10 equal to 2 into 5. So the factors of 20 are 2 into 2 into 5. So we have shown you the diagram how the numbers are splitted up, and it is called factor tree of a number. Next topic is HCF, highest common factor. How to find the highest common factor of prime factorization by prime factorization method. So you will know what is highest common factor. I am showing it with an example. Find HCF of 20, 30 and 40. What we have to do? We shall find the prime factors of 20, 30 and 40. So if I find the factors of 20, I get 2 into 2 into 5. If I find the prime factors of 30, I get 2 into 3 into 5. If I find the prime factors of 40, I get 2 into 2 into 2 into 5. So I write 20 equal to 2 into 2 into 5, 30 equal to 2 into 3 into 5, 40 equal to 2 into 2 into 2 into 5. So what we have to see? We have to see the factors which are common in all the three given numbers. I can see that 2 is present in all the three numbers and 5 is also present in all the three numbers. Therefore, the HCF is 2 into 5, the product of the common factors, which is equal to 10. HCF by Euclid's method. So you know better it as division method, but the proper name is Euclid's method. So remember in your exam question, determine HCF of 30 and 48. What we have to check? Which number is greater? 48 is greater. So for us 48 is dividend and 30 is divisor. So we have to divide 48 by 30. So I have shown it with diagram. I hope you will understand. When we divide 48 by 30, the quotient is 1 and the remainder is 18. Now the divisor, I have to bring it as dividend and I have to use the remainder 18 as dividend. So I get 1 as quotient and remainder is 12. 18 will be dividend for the next operation. So if I divide 18 by 12, I get quotient 1 and 6 remainder. 12 I have to bring as dividend and the remainder is divisor. So I get 2 as quotient and there is 0 remainder. Therefore the HCF will be 6. 6 is the HCF of the numbers 30 and 48. The last divisor is the HCF of the given numbers. I have given you some homework. You try to solve this and submit it on Monday evening. This is all for today's class. Have a great day ahead.